Now here we summarize what we did. Okay, we started with our system. We put that in the form AX equals B, where X and B are the column vectors, X, Y, and 0, 23. And A is a matrix. And we did the matrix operations. We got the solution, X, Y equals 2, 3, so that X is 2, Y is 3. And we plugged that back into the original equation and confirmed. That's what we've done. Now I want you to do that for this system. Okay, right there it is. This is what we posed. Okay, well, maybe you're going to actually do this, maybe you aren't. You should. But I'm going to go ahead. You should pause, you should stop, and solve it yourself so you can compare with what I do. But I'm going to do what I do. So I'm going to write down the matrix equation. This is 3, -1, 2, 1, multiplied by the X, Y column, and that equals the column vector 4, 1. Okay? Now I'm going to get another color here. I like purple. Okay. So this is the equation AX equals B. The next equation, the next thing we do in this solution is we multiply on the left by the inverse matrix. So we're just going to put our inverse matrix on both sides of this. Now, I'm not going to write out the inverse matrix. You've got the rule. You could write it out, but I'm just going to do it. I can do this very easily. First of all, the determinant 3, 1, -1, 2. This diagonal multiplies out to 3. This one gives me -2. So this minus this gives me 3 minus -2, which is 5. So the determinant is 5. I'm not going to write that down. I know that. Hopefully, my mind is still acute enough to remember that for a couple of minutes. Now I'm going to pull this back over here. Probably looks a little better. I don't know. It still looks the same to me. Okay, so the inverse is going to be what we get. Well, I'm going to flip this diagonal. I'm going to get a 1 here, and I'm going to get the 3 down here. Now, I'm leaving myself room to divide these by 5. Okay. Now I'm going to change the signs in this diagonal. It gives me 1, -2. So now this is, I got to divide by the determinant. That's 5. So right there is my inverse matrix. And then that's going to be multiplied by 3, -1, 2, 1, times the X, Y vector. And that's going to equal the A inverse matrix, this same matrix. And I got to go a little bit lower because of what I wrote there. Don't have an abundance of board space here, but that's going to be my 1/5, 1/5, -2/5, 3/5. Little bunched up there, but it's the same matrix I had here, multiplied by 4, 1. Well, the rest is really pretty easy. I could go on faith and say, well, this is going to equal the identity. And if I did that, I could just then write out X, Y equals, okay, well, 1/5, 1/5 times 4, 1. That's 1/5 times 4 is 4/5, and 1/5 times 1 is 1/5. Down here, -2/5 times 4 is -8/5, and 3/5 times 1 is plus 3/5. So that X, Y equals 4/5 and 1/5 is 5/5. I'll go ahead and write it out. -8/5 and 3/5 is -5/5. So that our X, Y column vector is equal to the column vector 1, -1. And there we've got it. Now, I never did this matrix multiplication because I know it's supposed to come out 1, 0, 0, 1. If I did my inverse matrix correctly, following the rule, it has to come out this. If it doesn't come out this, I didn't follow the rule right. Just two rules. Flip the main diagonal, put negatives in front of the numbers in the secondary diagonal, then divide by the determinant. Now, ideally, I would do this multiplication to check that I have the inverse correct, because it's pretty easy to do and it's easy to check. But another way to check if I did the inverse right is just see if I actually got a solution. So if x is 1 and y is negative 1, is that a solution to the equation? Well, I'm in the system. Okay, so system's 3x minus y equals 4. 2x plus y equals 1. Substituting x equals 1, y equals negative 1, we get 3 times 1 minus negative 1 equals 4. We get 2 times 1 plus negative 1 equals 1. Well, that's 3 plus 1 equals 4. Check. 2 minus 1 equals 1. Check. We must have done the inverse correctly. Okay. It's always good to double check. It's always good to both multiply this out to make sure you have the identity. And that also reminds you what we mean by the inverse. And then at the end, plug in and check.